as the volatiles. The krypton goes all around the Earth. Doesn't last that long. The strontium seems to go further for reasons that aren't entirely clear to me. The soot can get rained out. So it settled down near the reactor. It settled on the heads of the first responders. They were just, their clothes, their bodies, their hair were just covered in this kind of stuff. And this is why you're so concerned about the fire at Fukushima. Not because you're afraid the plume is going to get to Tokyo, although you should be afraid a bit. You should worry about it because you can't send firemen into a cloud of smoke containing this pile of radioactivity.
People who don't know, can you explain what half-life means?
Yeah, half-life. So radiation is a stochastic process. It's an even worse description, isn't it? It happens if you have a pile of 1,000 atoms. You have a pile of 1,000 zirconium atoms, and you wait 60 days. What you have now is a pile of 500 zirconium atoms. The other half have decayed already. You wait another 60 days. Well, you hand that to somebody else and say, aha, I have a pile of 500 zirconium atoms. They wait 60 days and they have 250. They hand that off to somebody else. They say, oh, I've got 250 sodium atoms. So half-life is the time for half of it to go away. That is an absolutely perfect curve all the way out. There's no deviation from that half. So don't expect there to be, after 5 half-lives, it's really all gone. No, after 5 half-lives, 2 to the 5th of it is gone. All but 1/32 is out. So this gives you something with a 60-day half-life. You're going to want to wait for 60 days times 5, 6, 10, 8 before you want to come back and have contact with it. So when we're talking about smoke, that's what these stay indoors advisories are all about, and that's why they should be taken seriously. I forget who the U.S. Homeland Security guy was who told you to put duct tape on your doors if there was ever a bioterrorism incident. Nobody took that too seriously. When the Japanese authorities say stay indoors because of the radiation, this is what they mean. If there is soot falling on the driveway, it's decaying and it's giving a huge radiation dose to your driveway, and that doesn't bother you. It does behave like soot. It doesn't behave like a gas, so it mostly falls down. So if you're staying indoors, it's not falling on you, and it's not giving you a dose. So, I mean, there are defenses against this kind of stuff. They aren't accessible to the first responders, but they're accessible to people in the cities. The other nice thing about soot is it's compared to strontium, compared to cesium. It's easy to clean. It takes time, but you can clean it up. You can wash it off of surfaces. You can brush it into a can. And you can restore a soot-contaminated city to a livable state with respect to this soot to a certain extent. Agriculture, fisheries, I mean, Chernobyl spent a lot of effort trying to clean up a lot of agricultural areas. The prime farmland. A lot of what they had to do was just dig up the topsoil, put it in a truck, and get rid of it. Sometimes you can turn it over, just kind of hide the radioactivity a little deeper. Which, and it's not you're hiding it forever. You want to hide it for the couple of years it takes for it not to be a problem anymore. The other thing to remember about this kind of table is, unlike chemical hazards, you don't care about each of these elements separately. If I tell you that you need to avoid, mercury, and you need to avoid PCBs, and you need to avoid, I don't know what else, plastic bottles because they have this arsenic derivative in them. You have to avoid each of those things separately, and there's a whole list of separate little chemicals that you would worry about. You need to worry about each of them. Radioactivity, you don't need to worry about each separate little thing. You need to worry about your dose, your total dose. You add it all up. It doesn't matter where it came from. You might worry about your dose to your thyroid and your dose to your bones, your dose to your skin. They might be a little different, but for the most part, you just need to add these things up. So that's all I had prepared. I wanted to say that a funny thing that happened in the wake of Chernobyl was, at least by the standards of the Soviet Union, a lot of decent epidemiological work was done on people who were exposed to this radiation. That's how we know about the large number of thyroid cancers. I don't know if people believe these numbers, but the 10,000, maybe 20,000 thyroid cancers caused by Chernobyl. One of the funny things that epidemiological survey found was very few cancers, but absolutely terrible health outcomes. They found lots of depression. They found lots of PTSD. They found lots of stress, lots of fear, because nobody told them anything. They were told, your town has been hit by a reactor, and we are trucking you all to Kiev. Leave everything behind and go, and then they get a handshake and see you later. They were not explained. Nobody explained to them what a sievert was. Nobody explained to them that they could get rid of the lead by washing their hair. They were just baffled, and so they spend the rest of their lives thinking that the reactor is slowly killing them, whether or not it is. So this was a huge educational communication failure, and it's absolutely unnecessary. It's an absolutely avoidable tragedy, and that's part of the reason I'm here. You all have the information. Your friends and acquaintances in Japan should have the information. You don't need to listen to authorities that tell you whether you should worry about whatever dose you have. Let's say count the millisieverts. Count them yourself. They'll be in the paper. You can get a Geiger counter. You can measure them. And you decide what your risk tolerance is. You decide how to respond. That's something that the people at Chernobyl were not given a chance to think about. My feeling is that the worst case radiation hazards from Fukushima are local. They're bad, very locally. Somewhat bad in a somewhat broader region, but still confined to part of Japan, and for the most part, they're mitigatable. The cities that get hit by this badly will be cleaned up. Tokyo is not going to be abandoned. And the best parts of that mitigation have already happened, and the early evacuation is, by God, the best thing that could be done. You don't have to worry about soot falling on empty houses, no matter how much of it there is. Chernobyl didn't have that luxury. People were already there when the smoke started falling. The next thing that we will need is watch out for if iodine-131 levels go up. Chernobyl, that all came in through food. Don't take an iodine tablet and keep drinking the milk. Just stop drinking the damn milk. But that needs to come from the government. That needs to be somebody credible putting restrictions on things and making sure unscrupulous farmers aren't selling meat on the black market or something like this. My feeling is also that the global radiation hazard is nil. These are large numbers of radiation, but the Earth is a large place, and there's lots of radiation here already. There's no evidence that this large amount of radiation, when it's spread over the world, as say the krypton-radon dose will, has any health hazards that are measurable in any way at all. So my feeling is this is really, really zero. California does not have to worry. Korea does not have to worry. China does not have to worry. Even Tokyo, so we'll talk about, Tokyo is not so far from Fukushima, a plume in the wrong direction, really bad luck on the weather. So, you watch the news and go indoors if you're told to. If you believe in the linear dose-response relationship, you should say, wait, how can a small dose given to 1 billion people is the same as a huge dose given to 1 million people? So how can you say that it's not a problem? I'd say if you're really worried about extremely low-level radiation causing very, very low-level cancer, the best way to stop that is to stop burning coal, not to stress out about exactly what's happening here. Moreover, we all have a limited amount of kind of psychic energy for worrying about things. It's a stressful thing. It takes energy. Takes energy for us. Takes energy for our friends in Japan. And I think you should. My message anyway. This is just obviously not a departmental statement. This is my personal statement. You should save your energy for the people affected by the tsunami, and for the real radiation hazard, which is the 50. Maybe now 100 plant workers who are still at Fukushima putting out the fires. Thank you, everybody. Thank you for coming. So, before we start the Q&A, Theo Theofanous would like to give a quick update on the status of the reactor. You can take the microphone, and here's the pointer.
In any case, I thought it would be useful to have up there, the pointer is this one?
Yes.
To have up there the geometry of concern here, this reactor. And most of the time, of course, we want to spend to answer your questions. But the latest is the following. The initial problem was with the containment, which is this part here. What you see here is the reactor vessel, and this is surrounded by that shell, and that communicates with this torus. It's like a donut that is all around. So this is what we call primary containment. So if this is integral, any radioactivity that is here is just like what Ben was showing, the little can contains everything. Now, at the beginning, of course, the problems arose because there was no power to cool these reactors. So the fuel became exposed, and the fuel started overheating, and then the zirconium that was there started oxidizing, and the hydrogen came out in this area here, and then it came out in this area here through those vents that you see here. And it looks to me now like, they haven't talked about it yet, but it looks to me that this chamber here was slightly damaged from the earthquake. So that when hydrogen started coming out of here, then we had an explosion in this room, and this caused a subsequent failure of this container. This is not good news because now we lost our primary containment. Still, I remind everybody that in order for radioactivity to come from here to the outside, it has to go through the water that is in there. And that water has a retention property. It has a property of keeping a lot of the radioactivity inside. However, this property is lost very quickly when this water gets overheated and gets near boiling. Still, it has some retention property, but it is not as good as if the water was cold. Now, suddenly, as of yesterday or maybe a day and a half ago, however, my concerns and the people that are involved in this sort of following it shifted radically from the reactor to this area here, which is the spent fuel pool. This has become a major problem because it looks like in the fourth reactor, you remember there are 6 reactors there. There are 3 reactors which were suffering because they were operating. So those are the reactors that were shut down, and now we had to deal with the decay heat, as you just heard. And the other 3 reactors were essentially without any fuel in them. All of a sudden now we hear that in the 4th reactor, we had an explosion at the top of the fuel pool. Now, why this is a concern? The concern is that there is a huge amount of fuel that is held in here, typically from anywhere from 4 to 6 cores. So that's equivalent like 6 reactors at the most, fully radioactive contained in those pools. And so that's the 4th reactor, which had shown up to this point no indication of difficulty. Now we have fire on the top of the pool, and we have an explosion, which destroys the roof of this building here, which is called the secondary containment. So to me, that's a very big concern because this pool here, once it is lost the water and lost cooling ability, the zirconium, the cladding oxidizes, and that becomes autocatalytic. Actually, near the end, when there's still some water vaporizing, that adds to the fire, so to speak, and is almost like catches fire. And then that